Hi, I'm Mrs. Huggard, and in this video, we're going to review some basics of polynomials, including classification and simplifying and expanding. To begin with, we need to look at the terms and the degree of a polynomial. You can see in this chart that the polynomials listed all have varying numbers of terms. Terms are separated by plus or minus. To count the terms of a polynomial, it's important that the polynomial is completely expanded. For instance, if there's anything to distribute, that should happen first. The degree of a polynomial is the highest exponent or sum of exponents in any particular term. If we look at this first polynomial, there is just one term, 2, and we call that a monomial. 2 terms is a binomial. In this case, it happens to be linear. 3 terms is a trinomial. In this case, it happens to be quadratic, but a trinomial does not have to be quadratic. Just like a binomial doesn't have to be linear. These are only examples. The number of terms determines the classification. The word polynomial indicates many terms. Let's look at some of the vocabulary. A polynomial is a variable expression whose exponents are whole numbers and whose coefficients are real numbers. We're going to talk more about that in a minute, but it's important that you understand that not every expression that we look at will actually be considered a polynomial. The important things here are whole number exponents and real number coefficients. Terms. When an expression is fully expanded, each term is separated by addition or subtraction. Remember that you have to expand the expression first. If there's anything to distribute, if there are like terms to combine, before you can tell me how many terms a polynomial has, you have to simplify or expand the expression completely. The degree of a polynomial is the sum of the variable exponents in a term. The degree of a polynomial is the same as the term with the highest degree. And we're going to look at some examples in a moment. Coefficients, I like to think of these as the numbers in front of the letters. Of course, technically these are variables and the coefficients are the number in front of them. Coefficients are always multiplied to the variables in the same term. And there is almost never a multiplication symbol there. So it's important that you know that that's the operation that's occurring. The leading coefficient is simply the coefficient of the first term when a polynomial is fully expanded and in standard form. Standard form means that it needs to be in descending order. If you recall from previous courses, when we put a polynomial in standard form, we list out the terms from the largest exponent first down to the smallest exponent or the constant term last. I know that there's a lot on this page, but what I want to focus on right now is what a whole number and a real number is, because we need to look at a polynomial whose exponents are all whole numbers and whose coefficients are all real numbers. So if the exponents are all whole numbers, we need to make sure you know what a whole number is. Whole numbers are basically all of the counting numbers, including 0. So 0, 1, 2, 3, and so on. Whole numbers do not include fractions. They do not include negative numbers. So what is a real number? Well, if you think about the real numbers, the opposite of real is imaginary, and you're familiar with imaginary numbers. That's any number involving I. Well, real numbers are everything else. So these are everything except for imaginary numbers. Real numbers are every kind of number you ever learned before you learned about imaginary numbers. It includes fractions, it includes negatives, it includes irrational numbers like the square root of 5 or pi. Those are all real numbers. So let's look at a couple of these and decide whether they're a polynomial. We're going to look at a few, and then I'm going to ask you to do the others on your own, and we'll talk about the answers in class. If we look at letter A over here, our test is whether we have whole numbers as the exponents, and I'm looking at the exponents, and they are all whole numbers. Don't forget that the exponent, when there isn't one, is a 1. And the coefficients, the numbers in front of the letters, those are all real numbers. That makes this a polynomial. And if we look, it is already in standard form. I can even give more specific information and say that this polynomial has a degree of 3. We don't use a term past trinomial, 3 terms. We use the more generic polynomial to name everything else. If you look at letter B, the first thing you may notice is that there is a negative exponent. And our rule for defining something as a polynomial is that the exponents are whole numbers. So this is not a polynomial because it breaks that rule. Do letters C, D, E, and it looks like G, there's 4 left here, on your own. Tell me if it's a polynomial, what the degree is, if that applies. If it is a polynomial, you'll give me the degree. And if it's a monomial, binomial, or trinomial, if you can state that as well. Let's quickly review some addition and subtraction rules. In this case, adding and subtracting polynomials is really as simple as combining like terms. And hopefully everyone remembers this. You've been doing it for years now. Like terms have the same variable with the same exponent. So x squared and x to the third are not like terms because their exponents are different. And so you could not combine the coefficients in front of those. Usually, you will see expressions written out horizontally, like in C through F. Occasionally, you'll see something like A and B, where the terms are sort of lined up under each other using addition or subtraction. Notice in B, the subtraction is in parentheses. This is very important because when you subtract an expression, an entire expression, not just one term, but several, you have to subtract each piece, each term. And so that means that we change subtraction to adding the opposite of everything that follows, which means this is going to become negative x squared. And this is going to become minus 2x. And this minus 1. So subtraction, if you recall from when you first learned about negative numbers, subtraction is adding the opposite. And that's just what we'll do here. Then we can add our like terms. We have a 2x squared and a negative x squared. That gives us positive x squared. We have a negative 2x and another negative 2x. Remember, we're adding. That gives us negative 4x. Notice that the x part doesn't change. The like terms are kept, the variable stays. Negative 7 and a negative 1 is positive 6. And your answer when you simplify this problem, is x squared minus 4x plus 6. You don't have to change anything. If it's an addition problem, these parentheses are basically just there to look pretty. You don't need them. Combine your like terms. I like to circle and underline or use other symbols to identify everything, and then you can complete the rest. You'll write these down and complete these for class. To multiply polynomials, you may recall that it's very important to distribute. And so what we need to do in this case is look at where our parentheses are located and what we're multiplying. In problem A here, we have 3x multiplied to everything in the parentheses. That means we're going to take that 3x and we are going to distribute it to everything that follows. Remember that when you multiply variables, you add their exponents. So 3x times 2x squared is 6x to the third. And 3x times positive 8x is positive 24x squared, because x's by themselves actually have an exponent of 1. And 3x times 9 is plus 27x. The last reminder I have before I ask you to do these other problems on your own is that sometimes it's useful to use a box instead of arrows, and most of you have learned this previously, to organize what it is you're distributing. So let's take a look at how this looks. Here we're multiplying 2x plus 7 times the other expression, 2x minus 5. Every piece in the first set of parentheses has to get multiplied to every piece in the second set of parentheses. And so to do that, we can make a box, 2x plus 7, down one side, or across one side, it doesn't matter which, and 2x minus 5 in the other. So one goes in the row, one goes in the column. And then you multiply each row and column and fill in your boxes with the product. 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. 7 times 2x is 14x. And 7 times negative 5 is negative 35. At this point, it's helpful to identify your like terms so that you can write down your answer already combining them. And if I combine those like terms, I'm going to write this in descending order. So I'm going to start with the 4x squared. I can combine my 14x and my negative 10x. This gives me plus 4x and minus 35. And this is the product of the problem, 2x plus 7 times the quantity 2x minus 5. Go ahead and try the other three on your own. Be careful. I suggest using the box to organize yourself, but you can use arrows as long as you multiply every term by every other term. Also, a quick reminder, don't forget that in letter I here, what it means when you raise something to an exponent. Remember that x squared means x times x. And x to the third means x times x times x. So x minus 1 quantity to the power of 3 means x minus 1 times another x minus 1 times another x minus 1. When you multiply these, you have to do 2 at a time. So you're going to do the first 2, get an answer, and then multiply it to the third quantity, again using the box or arrows. There's a short summary that I like to put at the end of the videos to make sure that you caught everything. Be sure to either rewind or pause the video along the way to write down problems